The overall goal of this procedure is to generate representative material of a larger scale industrial process for model validation and linking microstructural evolution to processing inputs.
This method can help answer key questions in the field of incremental forming techniques, such as how the combination of heat input and high levels of deformation affect in-service performance. The main advantage of this technique is that it is cost-effective and easily adaptable to different workpiece geometries and materials.
The applications of this technique extend toward process model validation and generating small amounts of process material for mechanical behavior assessment. Though this method can provide insight into metals spinning at elevated temperatures, it can also be applied to similar processes at ambient temperatures.
Because of the bespoke nature of the equipment and manual processing involved, visual demonstration of the method is critical, as the preparation steps are difficult to learn.
To begin this procedure, acquire as-cast workpieces machined to the mandrel size, such that the inner diameter runout is 0.2 millimeters, while the outer diameter retains as much cast surface as possible. Preheat a coffin furnace able to receive the entire workpiece to 135 degrees Celsius. Clean the workpiece with degreaser and place it in the furnace for an hour to prepare for thermal barrier coating application. After 1 hour, rapidly remove the workpiece from the furnace and place it on a coating jig. Using an automotive type paint sprayer, apply a thin layer of thermal barrier die coating to the inner diameter. After preparing the experimental apparatus,